at how to calculate for the maximum speed of a pendulum. And there are two ways, one which you could use a mass, one which you don't, but in the end, the process is the same. So we're going to find the maximum speed by using the conservation of energy, which states energy is conserved and there's no friction or anything. Now, before we get started, the maximum speed of a pendulum will always be at an equilibrium position, which is when it's directly down like this. All right, so in our question here, we're going to start with saying that the pendulum was lifted to a height of 0.2 meters above the equilibrium position, and then the other information is given in the picture. Now we see that there's also 0.05 meters distance above the 0.2 meters for the position which we start with, but it doesn't matter. The formulas that we're going to use, the height is going to be the height from the equilibrium position, so that's going to be this dotted line only, so you don't have to worry about this down here. Okay, so first way that you can solve for it is using the principle of conservation of energy. So the mechanical energy of one point is equal to the mechanical energy of the other point, because no energy is lost. So this will be your starting point. And then since we know mechanical energy is potential plus kinetic energy, we're going to equate that in here. Now, since we're looking for the maximum speed, we're going to be looking for kinetic energy. So I've labeled that our point here will be 0.1 and down here will be 0.2. So then we know when the object is at its maximum height, so that's here, there will be no kinetic energy, there will be no movement. And we know at the equilibrium position, there will be no potential energy, and there will be a maximum of kinetic energy. So let's just make that note. When it's down here, straight down here, potential energy equals 0. And kinetic energy equals maximum. Okay, and then when something is at a maximum height, such as a height that you manipulate it to be initially, the potential energy will be at its maximum and the kinetic energy will be 0 because it is not moving. Okay, this is EK. All right, so let's continue off. We know that potential energy is this, and we know kinetic energy is this. So we can cancel these out for the sake of simplicity. Since we're looking for the speed, it's going to be this one. So what we end up getting is 2gh squared equals the maximum speed of a pendulum. Okay, now if you substitute all the numbers in, you should get 1.98 for your maximum speed. Now we're going to move on to the next way to solve this problem. It's really similar, only that it's just longer, and it's a way that another way that you could apply the principle. So it's really similar to what we did last time. This is also right. If you calculate the mechanical energy at the first point with this formula, because that's what mechanical energy is made up of, you'll get this. And since this is a mechanical energy and there's no friction involved or air resistance, the mechanical energy in the first spot will be the same for the second spot because energy will not be lost. And first spot is the spot that is the potential energy not moving. Second spot we only have kinetic energy because we've discussed this earlier. So just something I want to point out especially here, we're going to substitute this in. Now, you might just be tempted to jump straight into your calculations here, and you could, but I just want to do this part for you. Okay, it's going to be divided by mass. It's obvious, but you might accidentally get tripped up with this half. You times it by 2, and then you accidentally might end up multiplying mass, but you should divide it The mass for our case is 0.25 kg. And velocity squared. Okay, let's just see. Okay, so the answer is this, which should be the exact same thing as what you did here.